Remember this name, Epic 2019-12552B. Hard to memorize, right? Looks more like a password than anything else. All right, here's an easier one. K2-18b. That's the name of the planet that could completely change what we know about life beyond Earth. Recently, scientists announced compelling evidence suggesting that K2-18b may actually host life. The discovery was made by researchers from the University of Cambridge in the United States, and if confirmed, this would be the first time in human history that extraterrestrial life has been detected. But what exactly are these signals they found? Are we talking about intelligent beings? Could we actually travel there to check? Let's break it down. First things first. K2-18b is what astronomers call an exoplanet, meaning it orbits a star outside our own solar system. In this case, it revolves around a red dwarf star called K2-18, which explains the planet's name. It's located about 124 light-years away from Earth, quite a distance. Not only that, but the planet itself is significantly larger than Earth, around 2.6 times its size. Its average temperature is estimated to hover near 5 degrees, 41 degrees. Cold, yes, but not uninhabitable. That's what makes this discovery so striking. Conditions there might actually allow life to exist. And now, new evidence suggests that K2-18b could indeed be home to living organisms. The story of K2-18b didn't start this week. It actually began back in 2015, when scientists first detected the planet orbiting its faint red star. Right away, it showed a fascinating characteristic. Its orbit placed it inside what astronomers call the habitable zone. The habitable zone is a sweet spot around a star, not too close and not too far, where conditions could allow liquid water to exist. Too close, and the planet becomes a furnace. Too far, and it turns into a frozen wasteland. K2-18b, however, lies in that delicate balance where life, at least as we know it, could survive. Imagine chilly weather averaging 5 degrees Celsius, cold, but manageable with the right adaptation. That fact alone sparked the big question. If it's habitable, could life already exist there? In 2019, things got even more exciting. Astronomers detected water vapor in the planet's atmosphere. And where there's water, there's a chance for life. Since water is one of the fundamental ingredients for biology, the discovery made K2-18b an even hotter candidate for exploration. Scientists doubled down on their research, eager to probe deeper into this distant world. By 2023, the planet was placed under the watchful eye of the James Webb Space Telescope. Webb is capable of analyzing the chemical fingerprints in a planet's atmosphere by observing how starlight filters through it. In other words, it can identify gases from light alone, an incredibly powerful tool for the search for life. In 2023, the James Webb Space Telescope revealed something extraordinary in K2-18b's skies. Alongside traces of water, the telescope detected carbon dioxide, CO2, and methane, CH4, in its atmosphere. This was historic, the first time carbon-based molecules had ever been identified in the atmosphere of a planet located within a star's habitable zone. Why does this matter? Because carbon is the backbone of life as we understand it. Every living organism on Earth is carbon-based. With this discovery, the pieces of the puzzle seemed to be falling into place. Scientists began to suspect that K2-18b might not only be habitable, but potentially teeming with conditions favorable to life. The data also hinted at something even more fascinating. K2-18b could be classified as a Hycean planet. This term refers to worlds dominated by vast oceans, essentially planets covered almost entirely in liquid water. If that were true, K2-18b would offer an ideal environment for microorganisms to emerge and thrive. After all, life on Earth began in the oceans. The possibility of a water-rich world orbiting a distant star lit up the scientific community. What once seemed like a distant, cold planet was now starting to look like one of the best candidates for extraterrestrial biology ever discovered. And then, in 2023, researchers dropped another revelation that would make headlines around the world. Just when the scientific community was already buzzing, another breakthrough came. Using the James Webb Space Telescope, astronomers detected unusual gases in K2-18b's atmosphere, compounds that raised eyebrows everywhere. These were dimethyl sulfide, DMS, and dimethyl disulfide, DMDS. Here's why this was so shocking. On Earth, both DMS and DMDS are produced exclusively by living organisms. They are what scientists call biomarkers, chemical signatures that indicate the presence of life. Specifically, these gases are released by marine phytoplankton and certain bacteria. No other natural, non-biological processes are known to create them here. Even more astonishing was the concentration. Measurements suggested that levels of these compounds on K2-18b were 20 times higher than those found in Earth's atmosphere. If true, that would imply not just life, but an abundance of biological activity. Some researchers even joked that the planet wouldn't just have oceans, it would be more like a massive soup of life. Adding to the mystery, the presence of these gases wasn't temporary. Repeated measurements showed that DMS and DMDS were consistently present, despite the fact that these compounds normally break down quickly. This persistence suggested that some ongoing process was continually producing them, further fueling the idea that life might really be thriving on K2-18b. The findings were so compelling that researchers began to make bold statements. Niku Madhusudan, an astronomer from the University of Cambridge leading the study, declared, "This is the strongest evidence so far that life may exist beyond Earth. I can realistically say that we may be able to confirm this signal within the next 1 or 2 years." Another scientist, Professor Megan, added, "If we confirm life on K2-18b, it would essentially prove that life is widespread throughout the galaxy." But before the world could celebrate, the scientific community reminded everyone of one crucial fact. Nothing has been confirmed yet. Astronomy doesn't work on hunches. It requires overwhelming statistical certainty. To officially declare extraterrestrial life, scientists demand a confidence level of 99.9999%, known as the 5 sigma standard. That's the gold benchmark used in physics and astronomy to eliminate any chance of error. At the moment, the discovery on K2-18b has reached only 99.7% certainty, which may sound high, but in science, it's still considered a 3 sigma result. In simple terms, it's exciting and highly suggestive, but far from definitive. So while the evidence points strongly toward biological activity, researchers stress caution. What looks like the beginning of a historic discovery could still turn out to have another explanation. Not everyone agreed that the gases on K2-18b had to come from living organisms. Several scientists pointed out alternative explanations. Catherine Hay from the University of Edinburgh and the Astronomer Royal for Scotland explained it this way. On Earth, these gases are indeed produced by microorganisms in the oceans, but even with perfect data, we cannot be certain that their origin is biological on an alien world. The universe is full of strange processes, and it's possible that unknown geological activity could generate the same molecules. In Brazil, astronomer Cássio Barbosa from Centro Universitário FEAE echoed this caution. He noted that gases like DMS and DMDS might also be produced through geological processes, for example, volcanic activity. Barbosa even highlighted a flaw in the findings. If these molecules were really present, their intermediate byproducts should have also been detected. For instance, hydrogen sulfide ought to appear in the atmosphere in quantities larger than the other gases, but it was completely absent. These gaps left room for doubt. Without those missing pieces, the argument for life remained incomplete. In science, extraordinary claims require extraordinary evidence. And while the signals from K2-18b were extraordinary, they were not yet airtight. Even if scientists wanted to verify the truth directly, there's a huge obstacle: distance. K2-18b is located 124 light-years away from Earth. To put that into perspective, even if humanity built a spaceship capable of traveling at the speed of light, the fastest speed allowed by physics, it would still take over a century just to reach it. That means sending humans or probes there is out of the question. For now, the only option is to keep observing from afar with telescopes. The ideal approach would be to create a complete map of K2-18b's atmosphere, but that is an incredibly difficult task given such distance. Barbosa summed it up with a blunt reminder. We can't even model the atmosphere of Venus with 100% certainty, and that planet is right next door to us. Imagine trying to do the same for a world 124 light-years away. In other words, despite the promising signals, there are severe limitations to what can be concluded. Astronomers are working with tiny fragments of light filtered through the planet's atmosphere. Every bit of data is valuable, but it's faint, hard to interpret, and always leaves room for doubt. Still, the possibility alone is enough to keep the scientific community, and the public, fascinated. The mystery of K2-18b only deepened as more questions arose. Some scientists even wondered whether the planet was truly the ocean world many hoped for. One strong clue came from the absence of ammonia in its atmosphere. A leading theory suggested that ammonia might be dissolving into vast oceans, which would support the idea of a water-covered planet. But there were other possibilities. Professor Oliver Shortall from the University of Cambridge raised a very different scenario. What if K2-18b was actually a lava world, covered entirely by molten rock? In that case, conditions for life would be impossible. Shortall reminded everyone of the harsh reality. Everything we know about planets orbiting other stars comes from minuscule amounts of light passing through their atmospheres. It's an extremely faint signal, and we have to interpret it carefully, not just in the search for life, but for every aspect of these worlds. This highlighted a core challenge: the limits of current technology. The James Webb Telescope only began operating in 2021, which in terms of human knowledge is incredibly recent. While it represents a revolutionary leap forward, it's still just the beginning of what we may eventually discover. For now, with limited data and many competing interpretations, certainty remains elusive. Despite the uncertainties, K2-18b remains one of the most promising targets in the search for life beyond Earth. To date, astronomers have confirmed the existence of 5,876 exoplanets, all waiting for detailed study. Yet K2-18b stands out because of its unique combination of water vapor, carbon-based molecules, and potentially life-supporting conditions. Even with questions about whether its atmosphere is influenced by biological or geological processes and debates over whether it's an ocean world or a molten planet, the discovery has sparked unprecedented excitement. Scientists, astronomers, and the public alike are captivated by the possibility that we might finally witness a moment in history when humanity begins to truly realize we are not alone in the universe. For now, the research is ongoing, and each new observation adds pieces to the puzzle. The data are exciting but incomplete, and the mystery is far from solved. Every telescope observation, every analysis brings us one step closer to understanding the truth about K2-18b and about life beyond our planet. The excitement lies in the potential. K2-18b could be the beginning of a historic revelation, remembered in the future as the moment humanity first glimpsed the possibility of extraterrestrial life. So, what should we take away from the story of K2-18b? Even though the evidence is incomplete and caution is required, this planet may mark a turning point in human understanding of the universe. Its water vapor, carbon-based molecules, and unusual gases hint at the extraordinary possibility of life far beyond Earth. Public interest is skyrocketing. People are asking, would you travel to K2-18b if it were possible? Could humans one day colonize such a distant world? And most importantly, do you believe in extraterrestrial life? These questions may soon move from speculation to reality. While scientists continue to study K2-18b, the broader context is thrilling. With thousands of exoplanets confirmed, the universe offers countless opportunities to uncover new worlds and perhaps even confirm that life is common throughout the galaxy. For now, all we can do is observe, analyze, and imagine. K2-18b reminds us that the universe is vast, mysterious, and full of possibilities. And as the James Webb Telescope and other technologies advance, we may finally answer one of humanity's oldest questions: are we alone? This could be the moment that future generations remember as the start of a historic discovery, the day we realized that life might exist beyond our home planet. What about you? What do you think about life on another planet? Share it in the comments below. And please, don't forget to hit that like button, subscribe, and turn on the bell. Thank you for watching, and see you in the next video.